Greetings, math friends. We are going to look at the function f of x equals the absolute value of x plus 2, and I want to be able to determine its domain, its range, and what kind of symmetry it has, whether it's even, odd, or neither. It's going to have self-symmetry because it's going to graph a V shape. One of the first things to do when starting to determine what a graph for this is to see if we can find out what sends this to 0. So we're going to look at just the inside and set it equal to 0. If I subtract 2 from each side, that says that x is going to be -2. When I plug -2 in for x, my f of x is going to be 0. So this is an x-intercept. And particularly, this is also the vertex of my graph, so we know that the graph sets on the x-axis. We need 2 more points. We know that x is -2. We want to choose one number smaller and one number larger. If I plug in -3, that's a number smaller. -3 plus 2 is going to give me -1. So when x is -3, I'm going to be at a +1 because the -1 becomes positive because it's absolute value. So at -3, 1, I have a point. And at -2, 0, I have a point. And then I'm also going to choose -1, one number larger than -2. If I plug -2 in here, -1 plus 2 is a +1. Absolute value retains the +1. So my graph is going to look like this. Once I have the sketch, I can think about the domain. The V shape's going to go on forever. It will spread across the entire x-axis here. Any vertical line that I put in here, I will be able to touch both the graph and the x-axis with that vertical line. So the domain is all real numbers. The next thing that I want to look at is what y values are going to work for this. That's going to be my range. And we see that the vertex is here, so it's going to include the x-axis and everything above it, but nothing below the x-axis has any portion of the graph plotted there. So our range is going to be that the f of x values have to be greater than or equal to 0, which is where the x-axis is. And then lastly, we want to determine symmetry. Symmetry, we're talking about even or odd symmetry. The even symmetry, when it's plotted, will have the y-axis acting as a line of reflection. It bisects the plot. We can see that the y-axis is just chopping off an arm of this, and the majority we see is over here, so this is not even symmetry. For odd symmetry, we want the plot of the graph to be able to be rotated about the origin and essentially land back on itself. Since this is off to the side, if we would rotate this around the origin, it would flip it into this 4th quadrant. It would be upside down. If we rotate it again, we're going to see that it's going to be in the 3rd quadrant, facing, opening towards the left, and then back to here. So we don't, this is the only real location that we can get the graph to look exactly like this. It doesn't have that rotational symmetry that we're looking for, so it's not an odd symmetry. So in this case, it has neither of the symmetries that we like to look for in a graph when we're talking about symmetry. Hopefully this has been a helpful, quick little video. Cheerful Calculations.